Okay, so today we are going to start the section, better to say, the most interacting and system which is basically application of electrodynamics, that is electromagnetic theory. So today this is the first class. Let's start the electrodynamics, basically electromagnetic theory. ওকে, এর আগে থ্রু আউট দ্য ইলেকট্রোডাইনামিক্সে আমরা যে বেসিক ইকুয়েশনস ইনভলভিং দ্য ইলেকট্রিক অর ম্যাগনেটিক ফিল্ডস ইউজ করেছি তার আগে যদি আমরা একটু রিক্যাপচুলেট করি তাহলে ইকুয়েশনসগুলো দাঁড়ায়, দেখো, ফার্স্ট অফ অল দ্য ডিফারেন্সিয়াল ইকুয়েশনস অফ গাউস ল giving you divergence of E equals to rho by epsilon naught. The terms have their usual meanings and I am writing them for the free space. So this equation says you if there is some charge, then divergence of this electric field at any point is rho by epsilon naught. Okay, so its physical meaning you will get if you take the volume integrations all over. So this will give you divergence of E dV, that is 1 by epsilon naught rho dV. So this will, after divergence theorem, will give you E dot ds, that is 1 by epsilon naught, and this will be, better to say, Q by epsilon naught surface integrations. So basically it measures the number of flux, better to say number of electric flux. So total electric flux you can calculate by E dot ds equals to Q by epsilon naught. That is the first equations. Okay. Next one, very similar equations you can have for the magnetic field. So magnetic field gives you the similar equations, and you can take the divergence of B and this is 0, you all know. Why it is 0? You all know that magnetic monopole does not exist. So if you use the same technique here, you will get closed path integrations B dot ds is equals to 0 again. So for any region you cannot have single monopole, that is north pole and south pole separately. You cannot go to the market and say give me only few north poles, I don't want south poles. So therefore north pole and south poles all will be together in same, therefore the total flux flowing out some region must be equal to 0. So this is our second equations. Basically তুমি যদি compare করো, these two equations are same if we had some magnetic source of magnetic charge, but as this is abstract concept, so divergence of B must be equals to 0. Now come to the third equations, which relates electric field with the magnetic field. Yes, this is the Faraday's law, which states that at some point if there is varying magnetic field, that will generate some changes in the electric field in this manner, and this is basically involves with the EMF. So if you take surface integrations of curl of E dot ds, that will be del del t surface integrations B dot ds. So right hand side gives you actually change of flux per unit time, and left hand side is basically give you E dot gl. So this quantity you all know that the EMF So EMF equals to del phi del t in some region. So rate of change of flux is equals to induced EMF. It is the integral form, and the differential form is curl of P equals to minus del B del T. What is the physically যদি এটার দিকে তাকাও, সো এই ইকুয়েশনস তোমাকে সুন্দর ভাবে ইলেকট্রিক ফিল্ড অ্যান্ড ম্যাগনেটিক ফিল্ডের মধ্যে একটা ইন্টার রিলেশনশিপ দেখাচ্ছে, যে টাইম ভ্যারিং ম্যাগনেটিক ফিল্ড প্রডিউসেস সাম ইফেক্ট in the curl of E. So what should be the fourth equations? What should be the fourth equations? Okay, it will be better if I write it as rho m by some constant, say something like this. আমি এমনি লিখলাম এটা যদি ম্যাগনেটিক ফিল্ড থাকতো। সো দিস ইজ ডাইভারজেন্স অফ ই ফ্রম ইলেকট্রিক চার্জ, দিস উড বি ম্যাগনেটিক ফিল্ড ফ্রম সাম ম্যাগনেটিক চার্জ, দিস উইল বি time varying electric field and producing some curl of E. So what do you think that should be the fourth equations? So obviously the fourth equation should be curl of B, just note the symmetry, is equals to, wait, we have equations, we already have equations involving curl of B for the conductor, and this is mu naught J, and your symmetry has broken. So don't be broken heart. This would be better if there would be some term with del E del T, then the symmetry will be complete, nothing else. So some person just 130 or 40 years, 20 years ago think no, symmetry should not be broken. Is this equations complete? জাস্ট আমি সিমেট্রির খাতিরে বলছি, এই ইকুয়েশনসটা কি কমপ্লিট? লেটস টেস্ট দিস ইকুয়েশনস, লেটস টেস্ট দিস ইকুয়েশনস checking, and that's why I have written in a red color, so there is some alert. So I'm taking divergence on the both sides. So divergence of curl of B, you all know that the divergence of curl must be equals to 0. So this is very easy, that's why I am laughing here, smiling here. So as it is equation, the same thing should happen in the fourth equations also. So if you take the divergence on the right hand side, mu naught is a constant. Wait, again there is a bouncer, and the bouncer says that the continuity of charge says u divergence of J equals to minus del rho del T. So in general this is not 0. How it is possible? And this is not equals to 0, so there is something wrong. Yeah, it would be 0, only it would be 0 when rho equals to constant. And basically what we have done so far, we have used these equations naming Ampere's circuital law, and that is used for the conductors. And you all know that for the conductors rho must be 0, rho must be constant. So for the conductor this equation is appropriate, but not for those cases where rho is changing with time, that is rho is not constant. So for that system, on that situations there will be something more, or this equation is complete. So that is, we are going to complete these equations and call it modifications of Ampere's circuital law by Maxwell. Modifications of Ampere's circuital law by Maxwell. Okay, so let's write that. But আমাদের মনের মধ্যে একটা কথা থাকবে, 3 নম্বর ইকুয়েশনের সিমেট্রিক কোনো ইকুয়েশনস যদি আমরা পাই, that would be Poabaro. I don't translate this in English. পোয়া 12. So what we expect divergence of J, that is minus del rho del T. This is the basic situations. Now just take both side here and say it is 0. So we have to maintain this 0, we have to maintain this 0, and now go back to the first equations. And from there you can replace rho as del T, and rho would be something epsilon naught that is equals to 0. Very good. Note, this is the operation with space coordinate, obviously del r. This is the operations with time coordinate, and they are independent of each other. So in that sense, I can take the divergence out, operation of divergence first, that is divergence of del T equals to 0. So basically this quantity J and this quantity must have the same dimension. They are in the same footage. So what I can do here, I can take the divergence of the entire terms J plus epsilon naught del E del T and set it to 0. Yes. So what should be this term? Let's name this term. Okay. If you think this quantity epsilon naught del E del T as del T of epsilon naught E, and you all know that what is this term, we have the informations about this name. Yes, this is displacement vector. This is displacement vector D. This is displacement vector D. Okay, and this is some sort of current density. So if it is current density, the entire term also will be current density, and this must be involved with displacement current. This must be involved with displacement current. So let's define this term as displacement current. Okay, so this must be displacement current density, whereas the J equals to, just put a C here, which is conduction current density, which will be conduction current density. Although this is not my fault, all call it as displacement current only. So that is, you can say, the mistake done by our Purkho. So you can define it also as displacement current, although this is basically displacement current density. Okay. So this time you can have divergence of blue color this. So this time we can say JC plus JD, that must be 0. JC plus JD, that must be 0 instead of Jc only. Okay. So a new quantity we have defined as displacement current density. So if we take this concept and let's complete the fourth equations. So our fourth equations was curl of B equals to mu naught. So we find that Jc cannot complete these equations alone. Must you have to add its partner Jd, and these two together makes your divergence of curl of B, that is mu naught, divergence of Jc plus Jd, that is equals to 0. Okay. So this would be the correct form, or better to say complete form, of the Maxwell's of the Ampere circuital law. So if you now write Jd in its explicit form, mu naught Jc plus mu naught epsilon naught del E del T. Here it is. So basically আমরা চাইছিলাম some equations del E del T equals to minus, curl of E, that is equals to minus del B del T এর মতো একটা equations, exactly curl of B, if there is no conduction current, that would be related with del E del T. So this time the equation is said to be complete. তাহলে কি দাঁড়ালো ব্যাপারটা? So all these equations together sounds as, number 1, just write down with me, divergence of E equals to rho by epsilon naught. Number 2, divergence of B equals to 0. Number 3, curl of E equals to minus del B del T, and number 4, this one. So these 4 equations together called Maxwell's equations. Maxwell's equations. These 4 equations together called Maxwell's equations. I'd prefer to write these equations in terms of E and H vectors because they are very easy to calculate. That unit are very simple. E, volt per unit length. H, current per unit length. Similar type of you can say unit they have. That's why I would prefer to write these equations in terms of E and H. So basically this is not a very tough job. Leave these equations as it is. Okay. If you multiply this equation by mu naught, definitely this will be 0. Number 3, curl of E. Okay. Now B equals to mu naught H. B equals to mu naught H. B equals to mu naught H. So minus mu naught del H del T, and number 4, there will be, okay, so if you divide this B by mu, so this, remove this mu from your expressions in the right hand side, and B by mu will be again H. So curl of H, that would be conduction current plus epsilon naught del E del T. So this is my favorite form of Maxwell's equations in term of E and in term of H. কেন আমি এটা করলাম দেখো, B is a little bit hazy terms, hazy in that sense. This you can think its units, or you can think of its physical concept. Rather E and H, they are very easy to think about them. Similar type of equations they satisfy, E satisfy, electrical circuit, A satisfy the equations for the magnetic circuit. E has the unit volt per meter, H has the unit ampere per meter. So I prefer these equations, and most of the times these fourth equations will be utilized. Although you have written these equations in free space, you can also write these equations for the any medium. Okay. So what is the revolutionary job done by Maxwell? Just to introduce this term called displacement current. এবার ধর ডিসপ্লেসমেন্ট কারেন্ট আমরা একটু ফিজিক্যালি বুঝে দেখি। সো ইফ আই আস্ক ইউ এ সিম্পল কোয়েশ্চেন্স, ডিসপ্লেসমেন্ট কারেন্টটা কখন অ্যারাইজ করছে? আনসার ইজ যখন চার্জ is changing with time. Now give me one example or a circuit where charge is changing with time, and spontaneously your answer will be capacitor. So let's consider the charging of some capacitor by some external battery. This is on switch. So this is V0, the voltage applied here. তুমি যখনই সুইচ করবে, there will be some current here which is called charging current. Okay, so charging current will compile the charges here. কতক্ষণ এটা হবে এবং চার্জটা এখানে তোমার বাড়তেই থাকবে। সো রো here is function of time, and this will stop when the potential difference will be exactly balanced, the V0. তো তার মাঝখানে তুমি দেখো এখানে চার্জিং অফ ক্যাপাসিটার, this phenomena was going on. So if let's represent them by surface charge density. তাহলে আমি যদি বলি what should be the field here, you all know that field is there is sigma by epsilon. If it is free space, then sigma by epsilon naught. Now what is sigma? Let's say sigma is at any time is equals to q by a epsilon naught. Therefore qt equals to a time epsilon naught e. E is the electric field developing there like this. Therefore, if you take the time derivative of q, so what is the time derivative of charge? You all know this is current. And there is constant area, constant epsilon naught, and dE dt. Not then what you call dE dt here. Therefore epsilon naught dE dt is basically current per unit area, and we name this quantity as GD. So physically দেখো তুমি কারেন্ট ডেন্সিটির এক্সিস্টেন্সটা এখানটায় বুঝতে পারছো কিনা? I think this is okay. Obviously there is some current flowing in the circuit. So this is conduction current. I am not talking about this. This is conduction current. I am not talking about this. So my question is to all of you, where is the existence of this current? What do you mean by IT? Where is IT? Where is IT? Before thinking further, I just want to confirm you this is either air or pure insulator, so cannot expect the charge to move here. The charge is compiling, not moving through the capacitor materials, yet you are calling this current. So you are calling current where there is no current, that is no flow of charge, yet you are calling that current. Think. তুমি বলছো এখান থেকে একটা কারেন্ট যাচ্ছে, ওকে, if I just, this is the very important thing right now, if you just cover this, no virus can attack this capacitor right now, so anybody will say there will be a charge flow throughout the circuit. তাহলে কারেন্ট কোথায় যাচ্ছে? এখানে যাচ্ছে, এখানে যাচ্ছে, এখানে যাচ্ছে, এখান থেকে এখানে যাচ্ছে। তুলে নাও, যাচ্ছে? আনসার ইজ নো, যাচ্ছে না। But yet I am calling it current because although there is no charge flow, but it creates the same effect in the magnetic field as this current can do. তাহলে এই যে তোমার কম্পাইলিং অফ চার্জ, it is equivalent to current as its effect is very similar to the conduction's current as for disturbing or creating the magnetic field. That's why we call it current, not for its flow but for its involvement in the curl of B. So that is the conceptual or physical interpretations of current density, conduction's current density. So you will be sent some assignment where you have to calculate conduction current density. Let's compare this to current, conduction's current and sorry আমি বোধহয় conduction's displacement currentটাকে conduction's current বলেছি. So let's compare this conduction's current and displacement current. তোমরা জানো conduction current density equals to sigma by E. এটা আমরা আগেই জানি, it represent the free charges, whereas newly জানলাম ZE that is equal to epsilon del E del T. I have no objection if you put some vector sign here. Okay. Basically আমরা যখন পড়ব কোনো ফিল্ড, সো আমরা মনে করছি this field has the form, time varying form like this. Let's consider this electric field. তাহলে আমরা যেটা ইলেকট্রোম্যাগনেটিক ওয়েভ আসে বা আমরা যেখানে যাব সেখানে টাইম ভ্যারিং ফিল্ডে কিন্তু আমরা মোস্ট কমনলি নিই। সেরকম একটা আমি এক্সপ্রেশন রাখলাম E equal to epsilon naught e to the power j omega t. So you can take del E del T. I am taking del because this expressions can involve R also. So that would be j omega E naught e to the power j omega t. That is j omega, this retain the form of E. So this retains j omega E. And this epsilon naught, don't forget to write here. So now compare their magnitudes. So JC by JD, that will be some sigma by omega epsilon naught. So omega is the frequency of the incident field on the medium. So for a particular medium of conductivity sigma and permittivity epsilon naught, if this ratio is greater than 1, তাহলে তুমি বলতে পারো জেসির ইনভলভমেন্ট বেশি, জেসির ইনভলভমেন্ট বেশি, ওকে, that the medium will act as conductor. Whereas if it is less than 1, then you can say the medium will be classified as insulator. Okay, তাহলে একই মিডিয়াম depending on the incident frequency of the incident field, can behave as conductor, can behave as insulator, can behave as conductor, can behave as insulator. Okay. I can give you a very common example. Consider behavior of pure water, where you can have sigma is about 10 to the power minus 3 unit, ohm inverse per meter. Epsilon naught, you all know that Dairy constant is 81 and it's 80. Epsilon r is 80. Therefore, Jc by Jd for our normal water, and obviously its magnitude, sigma by omega epsilon, that is 10 to the power minus 3 by, I just want to write the expressions of epsilon first, 80 into 8 point okay, 8.85 into 10 to the power minus 12 times omega. So think the water here where some electromagnetic radiation is falling. So if you put omega equals to about 10 to the power frequency 200. So if frequency of the incident ray is 200 hertz, say, so omega will be 2 pi into 200, and this will result Jc by Zd nearly 1106 greater than 1. So at this frequency range, your pure water would behave as conducting medium. But this is not so. Now, if you apply higher frequency, about 100 megahertz, that is omega equals to 2 pi into 2 pi f 10 to the power 6, put the same value nu sigma by omega epsilon, that will be 0.0022. So at this frequency the water will behave as insulator. ওকে, তবে তুমি যদি সি ওয়াটার ধরো সমুদ্রের জল, তা সেখানে সিগমাটা বাড়বে, অ্যাজ ইজ সল্টেড ওয়াটার ইজ কন্ডাক্টর, গুড কন্ডাক্টর। যদি না জানো তাহলে 3 Idiots দেখো। অ্যান্ড সেখানে তুমি দেখো মাইক্রোওয়েভ রিজিয়ন, তাতেই কিন্তু কন্ডাক্টিভিটি বিশাল বেড়ে যাবে। একটা অ্যাসাইনমেন্টের প্রবলেমস থাকবে, ওটা কিন্তু করে দেখবে। ওকে, আমি পিওর ওয়াটার নিয়ে করলাম। সো any medium that can behave as conducting medium or dielectric, that will depend the frequency of the incident electric field. Okay, ঠিক আছে। Now I am giving you few homework or some immediate consequence that you can draw from these Maxwell's equations. Obtain KCL, KVL equation of continuity of charge as the consequence of Maxwell's equations. Try to do it yourself. In our assignment class, this will be solved, or basically তোমরা এগুলো করতে পারবে. Now another interesting fact we want to reveal here, that is decay of free charge in medium. This charge is actually volume charge density. তো আমরা জানি inside of conductor you cannot place any charge, that will immediately transfer to the surface of the conductor. So conducting medium cannot hold the charge, and that will be a little bit different in case of insulator. So we are going to discuss that, and believe me, this can be explained from Maxwell's equations. So you are going to show me KVL, KCL, continuity equation of charge, all can be derived from Maxwell's equations. I am going to prove on additional thing, that is decay of free charge. So just go to our fourth equations, curl of H, that is equals to JC plus JD So we all know that JC equals to sigma E. I think you know these expressions. This is called Ohm's law in differential form. Ohm's law in differential form. Okay, this is the differential form of I equals to V by R. So let's put sigma E plus epsilon naught del E del T. Now again we take the divergence on both sides, that is sigma divergence of E plus epsilon naught divergence of del E del T. Okay, yes. So basically what should be the result here? That must be equals to 0 here. Divergence of any curl must be equal to 0. I'd be very happy if you just interchange this space derivative with the time 1 as del T equals to divergence of E. Take this constant inside here, so epsilon naught divergence of E, and I get very happy whenever I find some expressions like this, because we know that this is nothing but sigma by rho by epsilon naught. Note, this is no more resistivity, this is charge per unit volume. So you can have sigma by epsilon, don't write epsilon naught, otherwise it only justifies the free space, rho plus del rho del T, that must be equal to 0. So this is a very simple differential equations of volume charge density. Arrange this in the conventional form, and you all know that what I am going to do, I just want to solve for the rho as del rho by rho, that is minus sigma by epsilon del T. Now if you integrate this quantity, that will be ln rho equals to minus sigma T by epsilon plus say constant as ln rho naught. Rho naught কাঁদিও না, ln rho by rho naught, that is equals to minus sigma T by epsilon, that is rho by rho naught equals to e to the power minus sigma epsilon times T. So basically we have the expressions for the charge with now function of T as initial charge. Why I am saying it initial? If you take T equal to 0, rho will be rho 0. If you take T equal to 0, rho will be rho 0 as e to the power minus sigma epsilon T. Exactly. So you can find charge is decaying from rho naught with time in exponential manner. And whenever you plot these sort of equations, one thing immediately comes with your mind: what should be the period in which the charge decays to some reference level, obviously, and that is what should be the time when the charge decays up to its 1 by e times. Okay, let's say this is the time tau. This quantity always is dimensionless. So if you put T equals to tau sigma by epsilon naught, rho T will be rho T bread. So this bread will be rho naught by 1 by e. So in this time duration, you can say it's relaxation time, the charge will decay up to the E equations, and that is nothing but epsilon by sigma. So let's justify, or physically let's think what this amount may be. So epsilon naught is nearly about 10 to the power minus 12, nearly about. It is not greatly, largely varied for every terms. For water it may be 80 times, or maybe 4 times, or maybe 10 times. But drastically changing term is the sigma. Conductor the conductivity is of the order 10 to the power 7. So tau c for conductor will be 10 to the power minus 19 second. So if you have some conductor, like this, and if you put some charge inside this, so this charge will decay with the rapidity of the order 10 to the power minus 19 second. Pati Bangla kothay bolo, immediately. So the charge will just decay from the volume of the conductor. Okay. So instead of the conductor, consider some particular type of insulator like quartz. For the quartz, conductivity is very low, and for typical quartz it is 10 to the power minus 14, and at that section tau for insulator would be 10 to the power minus 12 plus 14, that is 100 second. Okay, so for the insulators, you can find the charge inside the material a little bit time also. So there will be few problems. You can have to calculate the relaxation time or tau. So these are the very simple, immediate, better to say, consequence you can find from the Maxwell's equations. But we need more. So let's get away from these Chunoputi expressions. Okay, let's consider these 4 equations and couple them, not as the 4 equations separately, but take them together. What will happen? What are the 4 things? Okay, so let's come to first free space. That is rho is 0 and no current is there. Rho is 0 and no current is there. So under these situations, our divergence of E will be 0. Divergence of B, okay, I prefer to write E is 0. Curl of E minus mu naught del H del T. Curl of H, J is 0, JC is 0, so you left with del E del T. So name them 1, 2, 3, 4. Now come to equation number 3. Take curl to 3. So you have curl of E, curl E, that is minus, don't ask me why I have interchanged these time and space operators. I have already explained this. So taking curl gives the equation 3 a peculiar form, although we know the vector identity here, and that will give you minus grad of divergence of E. Okay, grad of divergence of E minus del square E here. Yes, and there is, as it is, minus mu naught del T of curl of H. Yeah, so equations tells you, I can simplify your expressions, put 0 here, so there will be only del square E, and equations 4 says, okay, you can express these equations only in terms of electric field if you put del del t curl of H as epsilon naught del H del T. Wow. So the expression should be just like mu naught epsilon naught del 2 E del T2. So for the free space, you can have the soft equations. If you take this particular value, so these equations will go for the any dielectric medium. So let's talk about only free space. So what type of equation this is? There is double derivative of space and there is double derivative of time with some constant here. Okay, if you go for its x component, this will be del 2 x del T2, that will be mu naught epsilon naught del 2 ex del T2. Wow. So this parameter, if you remove this parameter by remove this quantity by some parameter, so yes, this is wave equations in 1D. So it's one component will give you 1D wave equations, that is the entire terms actually represents wave equations in 3D. And what will be the velocity here? With velocity, there is 1 by v square. So this velocity will be v equals to 1 by root mu naught epsilon naught. So this is wave equations with velocity 1 by root epsilon naught mu naught. Now, where have you তুমি প্রথমবার কোথায় জেনেছিলে মিউ নটকে? When you first met epsilon naught. So jab we met, it was in Coulomb equations. Jab we met, it was in Weissager's law. So these are some constant real involved in free space in Coulomb's law and Weissager's law. Okay. Now I want to put their typical values to calculate V. 8.85 10 to the power minus 12 into 4 pi 10 to the power minus 7. 1 by root over, I have the calculator, you can also use that. So this will be 8.85 into 4 into 3.14, that is 111.156 into 10 to the power minus 19. So into 10 to the power minus 19. Okay. So just take root of this answer. So this is 1 by 3.334 into 10 to the power minus 9. So if I take the inverse of these expressions, this gives me 2.99939 into 10 to the power 8 meter per second. That is only thing you can believe in this world, in this universe, that is velocity of light. Can you imagine this? So with this speed only one thing can proceed. We all know that, as we know the relativity, and that is light wave. So there is no doubt you have the expression of electric field which must be one component of light wave. That's it. This is your job, your job. Immediate pause this video, immediate stop this video and take curl of equations 4 and comment me whether you get the similar expression for magnetic field also or not. If you get this sort of expressions, then you have to conclude magnetic field also must be one component of light. And now you can justify telling the light as the electromagnetic wave. Okay, you can say light as electromagnetic wave, and that is the first success of Maxwell's equations. So these equations are not only to explain the KVL and KCLs. These are the expressions which shows you can obtain the nature of the light only writing down 4 basic electrodynamics equations. And that's why that man Maxwell was taken as the god of science before 2 more names. And you put those expressions in your t-shirts, and you put those expressions as the cover page of every electrodynamics books. Okay, so that's it. So light is electromagnetic wave, and that is justified by the field. Okay, just think. Now, what should be this chapter we proceed with? One by one, we are going to explain all the nature we have already informed. I am giving you the term informed. As you know, light is transverse wave. As you know, light carries the energy. As you know, light gets reflected, light gets reflected, light gets polarized, light showing total internal reflections, etc., etc., etc. So all those phenomena, if which you are, I'm not going about the origin of the radiations, that will be beyond our topics. But তোমরা যে লাইটের ঘটনাগুলো জানো starting from class 6 or 7th standard, we are just going to explain the same thing, but in terms of the electric and magnetic fields. Okay, this topic is going to be very interesting soon. তুমি জানো রিফ্লেকশনস করে লাইট, আমরা বলবো লাইট কখন রিফ্লেকশনস করে, যখন লাইট একটা মিডিয়াম থেকে অন্য মিডিয়ামে ইনসিডেন্ট হয়। সো দেয়ার শুড বি সামথিং হ্যাপেনিং অ্যাট দ্য বাউন্ডারি। ইয়েস, উই নো দেয়ার উইল বি সাম চেঞ্জেস ইন দ্য ভ্যালুজ অফ ইলেকট্রিক অ্যান্ড ম্যাগনেটিক ফিল্ড, and those are called the boundary conditions on electric magnetic field. So those conditions will explain the reflections and refractions and polarizations, especially Brewster's law. Okay, so those topics will come one by one. First of all, let us explain the nature of the lights. Before that, those equations I am giving you, those equations are given to you. Basically, I am writing the equations of electric field again. This was how much? I forget. Okay, don't forget. Mu naught epsilon naught del 2E del T2. So if you get its plane wave solutions, it will appear with a very common form as E at some point at any time t will appear as E naught e to the power j k dot r minus omega t. So that is one expressions of plane wave solutions of this field. You have already these solutions you have done in your previous semester. Okay, I just want to show you one physical significance of this term, why it is called plane equations, plane wave. Okay, similarly you can also write down the expressions for the magnetic field also, as they are satisfying the similar relations as, put a vector here, e to the power j k dot r minus omega t. You all know that k is equals to 2 pi by lambda, and if you give it a form of a vector, this is called propagation vector. So if I just plot these expressions here on the Cartesian coordinate, so this is the propagations vector. This the light is propagating along these directions. Now let's explain this, why it is called plane wave. Imagine a perpendicular plane to it. Okay. Let's make a hole here. Don't do this in your examination room. I am just want to show you this vector is going through this. So this is the plane, let's say PQ plane, which is perpendicular to the K at any point. So এটাকে আমরা একটু সোজা করে আঁকি। সো এটাকে আমরা এই ছবিটাকে আমরা একটু ওরিয়েন্টেশনস করে দেখব। এইভাবে দেখছি। সো this will help us to present you better. Okay. So let's say this is the origin, O or O. O. Now at any point, at any time, take R, the position vector of any point. Okay, bara korchi na. This angle is theta. So this component will be k dot r equals to kr cos theta. That is k cos theta times r. Now what is k cos theta? What is k cos theta? If it is k, so if it is theta, okay, let's set the value k up to this. So k cos theta will be this term. Does it make any sense? Okay. That will be r cos theta rather. Okay. Put k here and cos theta here. So this will be k cos theta. So this quantity will be, r cos theta. Okay. So this quantity will be r cos theta. So if you go for the any further angle for another vector, the cos theta component will be the same everywhere. Okay. ठीक है? So k dot r will represent this particular plane here. K dot r will represent some particular plane over there. Now time will evolve, time barbe. If time will increase, and you all know that this phase must remain constant. This phase must remains constant. So for that particular angle, as k is constant, so as omega t is increasing, k dot r should also increase. So for t to be increasing, k dot r also should increase. Now your k is constant, and for a particular directions theta is constant, so r should change, r should also increase accordingly. So if r is increasing accordingly, so you will get the immediate next plane and then the next plane. So with increasing r, you will go to the next plane and the next plane and the next plane. So you can see proceeding of the wavefront like this. That's why we call this plane wave solutions. Okay, so as increasing time is increasing, k dot r have to increase, k and theta remains constant, so r have to increase, so you will get the propagations of this plane over there. That's why we call it plane wave solutions. If you take in on dimension, this will be very easier to explain. Okay, now let's write down few results and give a very much concentration on this. For electric field, I have E0 e to the power j, let us say I k dot r minus omega t. You can prove this later, right? Right now, let us write down few expressions. 1. Expression of del E del T. See, as it is exponential term, so its derivative will be also exponential, leaving that coefficient of t out of this. So just write down it as I omega, and the entire term m k will give you E. কি বললাম, t দিয়ে ডিফারেন্সিয়েট করছো, t এর কোএফিসিয়েন্টটা কি আছে, minus I omega, take the minus I omega here, and remaining term or again will be E vector. So please tell me what would be del 2E del T2. So this I minus I omega will appear twice, giving you minus omega square E. Minus I omega. Multiply these two will give you minus omega square E. So this is the time derivative. Now take the divergence of E. What is divergence of E? What is divergence of E? Divergence of E is the differentiation with respect to R. So what is the coefficient of R? Just note that I am not going to prove this, and from that write it as ik dot E. I am not going to prove this. We can prove this in your assignment class and you can try yourself. So this would be ik dot E. আমি আবার বলছি এটাকে আমি কিন্তু প্রুভ করলাম না, because lots of things has to do here, so you can prove it yourself or in our next assignment class, but I can suggest you just break these equations in component form and try. Okay, take its one component and try. Number 4, now come to the symmetry. If there is curl, no doubt there will be curl, cross product. Dot থাকলে dot হবে, so you are differentiating with respect to R actually, so dot থাকলে ik আসবে, cross থাকলে ik cross আসবে. And 5 del square E, this term will give you del square E, this term will give you, okay, ik দুবার আসবে, ik and ik, that is minus k square E. So pause this video and write it yourself, and also repeat the same technique for magnetic field. As the magnetic field has the similar expressions, only replace E by H. So I am very soon going to use these expressions here. We are going to explain the orientation of electric magnetic field with the propagations vector. Okay, so first of all come to the electric field. দেখো আগের কাজগুলো মনে রাখো. First use the expressions divergence of E equals to 0. Okay, তুমি যদি আগের কাজটাকে মনে করো, যে এক্সপ্রেশনসগুলো যেটা বার করেছিলাম, সো দ্যাট উড বি I k dot E that must be equal to 0. It immediately gives you k vector perpendicular to the E vector. So if you think the electric field alone, and if it is the directions of the k vector, you will get electric field is perpendicular to the direction of propagations. So immediate conclusion is electric field as wave appears as transverse wave. Okay, so electric field is transverse in nature. Now you know what I am going to write down here immediately. So that is about the magnetic field. So if you now use the second equations, that is divergence of H, this is always 0, that may be free space or not. So similar conditions gives you ik dot H, and your conclusions will be k perpendicular to H again. So not only electric field, magnetic field is also perpendicular to the direction of propagations, and that is magnetic field. Now one thing appears here, one thing, so okay, up to this it is, we are confirmed that both the fields propagates as transverse wave, and you can say light is transverse wave. But how to draw the electric field, magnetic field and direction of propagation? So is it, if I draw on electric field, so what should be the propagations, what should be the magnetic field, in what should be the directions of the vibration of magnetic field? Is that along these directions or these directions or these directions, or immediately parallel to the E? Okay, so for that we have to bring our next two expressions. Actually আমরা দুটো বোলারকে খেলিয়েছি, এবার থার্ড বোলারকে খেলাও. That is curl of E is equals to mu naught del H del T. So আগের জায়গা থেকে আমরা পাচ্ছি curl of E, that is I k cross E immediately gives you minus mu naught I omega H vector. Okay, so remove all these terms, I and minus will be plus, and leave you with k cross E equals to mu naught omega H. Now the interesting fact is, if you assign k vector along y cap and choose E vector along z cap, immediately H vector must have to appear along you know x directions. Wow, so their orientations is very much similar to our coordinate axis, and you can now plainly draw like this. So if this is the direction, if this is the direction of propagations along y cap, this will be the vibrations of electric field along z cap, then magnetic field must have to vibrate along x directions. Wow, so that is the relative orientations of electric field, magnetic field and direction of propagations. Now let us draw the wave. Okay. Okay, I suggest you to pause this video and obtain the same results from the fourth polar, that is the fourth expressions, that is curl of H equals to epsilon naught del E del T. And I think you should get, you can verify this from these expressions. Just do it. Just do it. Okay. So verify these orientations from these expressions also. Now let us draw the propagating vectors. So if I give you the vibration of, say, electric field here in this format, okay, let's draw, this is the, okay, sorry, and pause this video, draw the magnetic field right now. Okay, I think you have done the mistake as I expect. You have drawn the magnetic field like this. Is it? If so, then hold on. If so, then hold on. And please tell me who gave you the authority to start electric field and magnetic field from the same point and you met them in the same point again. That is only possible if there is no phase difference between electric and magnetic wave. We have not yet enough conclusions that there is no phase difference between electric and magnetic field. Okay, we have no such evidence yet. We have discussed that. Okay, let's discuss about the when this phase difference appears. So for that, let's give you some demo. Let us consider x by y, ratio of two variables, ratio of this quantity as a plus ib. So you can have x by y equals to root over a square plus b square e to the power I tan inverse b by a. Is it? Therefore x equals to root over, okay, I just write down this quantity as, say, p e to the power I theta times y, where p is this quantity and theta is this quantity. Let y equals to y naught e to the power I phi. Then x will be p e to the power I theta times y naught e to the power I phi, that is py y naught e to the power I theta plus phi. So let me ask you one questions. What is the phase of x? So phase of x is theta plus phi. What is the phase of y? Phase of y is phi. So what is the phase difference? This theta, this theta, this theta, this tan inverse divided by a is the phase difference. Now when there will be no phase difference, if phi is, if theta is 0, if theta is 0, if theta is 0, that is if b is 0, that is if the ratio is real. So if e by x by y is a real quantity, then there will be no phase difference. Let us use this technique for x, a, e and h, and let's find whether there is any phase difference between e and h. So as we say, I am going to use these relations again and again. Curl of E equals to minus mu naught del H del T. So this is I K cross E, that is minus mu naught omega plus I, and it appears as minus I omega, and H vector. Remove I and now say K cross E, K cross E, K means Y cross E, that is Z, Y cross Z gives you H, that is the X, that is the along the same directions. So K E must be equals to mu naught omega H. Therefore value of E by H, that is mu naught omega by K. Now if this ratio is real, we have no doubt, there will be no doubt there will be no phase difference between E and H. Now explain whether this is real. Mu naught is real quantity, frequency is real quantity, and we have just show that K is also real quantity. So where from you get these conclusions? Let us use our fifth Bowler. So our fifth Bowler is the wave equation itself. So use that results of that expressions here. So this will give, as is there is double derivative by space part, so that will be minus K square E, that quantity will be mu naught epsilon naught, and there will be minus omega square E. So for the non-zero value of the fields, we have K square equals to mu naught epsilon naught times omega square. That's it. Now these quantities are real, these quantities are real. Okay, you can also write it as K square, K equals to mu naught omega naught mu epsilon naught mu naught omega, that is omega by C, as it should be, K equals to omega by C. So from here you can conclude K is a real quantity. So as it is real quantity, there will be no phase difference between them, and hence you can happily draw this diagram. And can represent the light wave here. Okay, so that is our light wave. That is our light wave. Okay. So in today's discussions up to this, we have using Maxwell's equations have derived the wave equations, solve it and find the nature of the light wave. In the upcoming videos, upcoming classes, there will be lots more. So wait for that, or you can proceed yourself.